It's pretty uncommon to run into a systems of equations with more than two variables, but it does happen every once in a while. It's not that common though, like I said, and half the reason I'm making this video is because I think it's really good practice for making equations, particularly those little tiny equations in text that are hard to see. So even if you're not too concerned about this problem type, and I really wouldn't be unless you're really trying to get a max score, I may watch this video anyway, just to get the practice making an equation. I'm making several equations. So Nate has $3.49 and change. He has 6 more pennies than nickels. There's our first equation. 6 more pennies than nickels. You may want to go back and look at make an equation. Because what you'll do, what a lot of people do, I don't know if you will, but what a lot of people do is they'll say P plus 6 equals N. Nate has more pennies than nickels. He has more pennies. So to make pennies equal to nickels, I got to add to the nickels. Second equation, 4 more pennies than dimes. Again, he has more pennies, so the 4 goes with the dimes. 2 less pennies than quarters. Now, I could write this a couple ways. Now, obviously, I could write these equations in terms of nickels or whatever, too. But I may do this, just because I have everything in terms of P right now. He has more quarters right now, so I need to subtract quarters from pennies. How many dimes does Nate have? Okay. So how many variables do I have? Pennies, nickels, dimes, quarters, 4 variables. I don't have any equation that relates them all together right now, so I need to do that. Okay, $3.49 and change. So I could say pennies plus oops, a little too close. Plus nickels, plus dimes, plus quarters is equal to $3.49. But I'm not quite done yet. If I leave it just like that, I've got a problem, because that's saying that the number of pennies plus the number of nickels plus the number of dimes plus the number of quarters is equal to $3.49. That's not entirely accurate. These things are weighted differently, right? A penny's 1 cent, nickels 5, dimes 10, quarters 25. So I have to account for that. It's kind of like a weighted average in a way. Value times number. P and DQ represent the number of each type of coin I have, but I have to also account for the value. Now, I'm going to do a little trick that I like, and I'll explain in a second. I'm using 1, 5, 10, and 25 instead of 0.01, 0.05, 0.1, and 0.25. And I'm removing the decimal from $3.49, 3.49, to make it 349. Essentially what I've done is I've multiplied everything by 100. I can do that because I did it to every single thing, every single term on both sides of the equation is fine. Why did I do that? Because I don't want to deal with those decimals. I don't want to deal with 0.05n, 0.1d, 0.01p. It just was going to make things a little easier for me. Now I have all 4 variables in one equation. I got to get it down to one variable in this equation so that I can solve it. So I could put everything in terms of pennies. I think that's the way to go, right? Because I have everything. Pennies is my touchstone. Pennies is with nickels, with dimes, and with quarters. But the way I originally wrote my equations doesn't really help. Because for me to substitute pennies in for nickels, I need to have this as n equals. So I'm going to rewrite these equations. So I'm going to subtract 6 to get the p, or to get rid of the 6 with the n and move it over here. So I'll have n is equal to p minus 6. Same thing with the dimes. Dimes is equal to p minus 4. Same thing with the quarters. Quarters is equal to p plus 2. Now I can go ahead and plug things in. So let's rewrite n, d, and q, substituting in this side of the equation for each one. So this will be p minus 6. This will be p minus 4. This will be p plus 2. Boom. Now I have one equation, or excuse me, I have one equation with one variable. That's solvable. First step is I got to distribute. One of the mistakes I see on this, people will get this far, they get excited. It's kind of like catching or running before you catch the ball. They'll forget they need to distribute the 25 to both, the 10 to both, the 5 to both. So let's go ahead and do that. 5 times p, we'll start with our 1p. 5 times p is 5p. 5 times negative 6 is negative 30. 10p minus 40. 25p plus 50 is equal to 349. Start combining like terms. This will be 41p. By the way, just this is not something you need to remember, but if you do, great. They typically ask this more than two variable system of equation question with this change thing. This is the place I see it is. It's a change question. How many quarters does he have or whatever. If you do it, it's the coefficient in front of the variable. Once you collapse it in, once you combine all your like terms, will always be 41. 1 plus 5 plus 10 plus 25. It always works that way. It doesn't matter which one you're substituting in for. One of those funny little asides. Combine my constants. Negative 30 plus negative 40 is negative 70 plus 50 is negative 20. Oops. Let's make that a minus sign. Go ahead and start moving stuff over. 369 is equal to 41p. And 41 goes into 369 9 times. You have 9 pennies. The question asks for dimes. How many dimes does Nate have? Well, he has number of pennies, 9, minus 4, he has 5 dimes. This is a really good example of a problem that's so long and complicated that it's very easy to just put that non-answer down, put the pennies down. So again, I really encourage you to box, underline, circle what they're looking for when you have these complicated multi-step problems. The halfway answers will be there more often than not. Of course, 9 is our halfway answer. Don't let it trip you up.